gente continua a nossa programação com a palestra Simplificando a Cibersegurança de OT e como construir um plano de ação. Antes de convidar o nosso palestrante ao palco, eu vou apresentá-lo. Ele é arquiteto de soluções na TX1 Networks, líder global em segurança OT ICS, com experiência como engenheiro de segurança de rede para organizações em diversas indústrias. O trabalho dele está focado em todos os aspectos do design, implantação e implementação de estratégias de cibersegurança para eficiência operacional e um processamento seguro. Ele possui mais de 25 anos de experiência em segurança, representando empresas de segurança desde hardware até segurança em nuvem, soluções de governança de dados e empresas de segurança de endpoint. Ele já trabalhou anteriormente para British Gas, Mazda Motors da América, Mitsubishi Motors da América do Norte e a empresa de segurança em nuvem Scalar. Senhoras e senhores, ladies and gentlemen, please welcome Mr. Mark Porter.
Thank you. I know this clip isn't exactly accurate for oil and gas, but I just really liked it and I love the animation, so I put it up. Good morning, my name is Mark Porter. First, I must apologize for not speaking any Portuguese whatsoever, except caipirinha. That's the only thing I needed to know. Thank you for leaving me some of your time to talk about OT security, and I want to make this into something of a plan that you can actually look at and potentially even implement. Sometimes things are too complicated, and you can't actually get around to do them. In OT, we have all sorts of restrictions and controls, so we need to be able to implement something, and how can you actually go ahead and do this? I think I was just mentioning I worked right out of college in England. I worked for British Gas, and one of the first things I did, and this is going to be a bit of a theme throughout all of this, is building a model of the British Gas system, a computer model. And the idea behind this is that if I have a model of what the gas pipeline actually looks like, I can tell if there's a problem with this pipeline, or if we need to make a change to this pipeline, how will it affect the rest of the pipeline? So this model was essentially the downstream system, and with a little bit of overlap with the midstream. The overlap with the midstream involved those massive, great big compressor stations that did the step up or step down of the pressure in the gas pipelines. And yeah, we wanted to model it. We were particularly interested in different times of years. We had a model of actually the national weather, so we knew what was the coldest day of the year, what was the coldest time of the day, so that we could say, okay, if everybody goes home at 6 o'clock on a Monday in February the 2nd, which is the coldest day traditionally, can the gas pipeline handle this amount of load? It was a strange little idea, but it was a brilliant, brilliant thing to say, we want to model this entire structure. Now, this was quite a long time ago, literally, a long time ago. And I distinctly remember thinking at the time, okay, we're building this nice, shiny new computer model of a gas pipeline system that was well over 100 years old. Obviously, some of it was newer, and as you can see, some of the original stuff came from 1780. So really, really old pipes. Some of these pipes were so old they were rusted through and they didn't even function anymore. They were a hole through the ground with no pipe, kind of crazy situation. But I think this is something that happens in OT. We're often working with very old equipment and very old technology. And I just saw a maintenance article about some of those step-down or step-up compressor stations, the compressor stations. And this was a new article just from, I think, late last year. And the article was talking about how they're going to have to decommission some of these compressors. And I just thought it was amazing that these compressor stations were implemented in 1970. So these big gas turbine things were now 50 plus years old, and we're still using them. And the technology that's operating them is probably not 50 years old, but it's still very, very old computer systems that are managing these compressor stations. And they're only just now being decommissioned. And the only reason they're being decommissioned is because of new emission standards. They produced a little bit too much additional gas that you didn't want, so we had to actually decommission them. But it was an interesting concept to build a new system on old 100-year-old pipelines. Pretty good job by Rolls-Royce, by the way. I mean, if you see all of the planes, they're still flying with Rolls-Royce Avon engines and things like this. So, why have we not been able in OT to implement security? This is what we really want to This is what we really want to talk about. There's a lot of reasons that we don't implement security, or we can't implement security, or we don't want to implement security. And I think probably you'll agree that the worst one, or the most obvious one, is downtime. Essentially, we can't take on downtime. You're in oil and gas, or electricity, and any kind of services, but even production lines. We work with a lot of silicon manufacturer systems, and if you stop the production line, all hell breaks loose, everything shuts down, you lose millions of dollars in that production line. Same thing with a gas pipeline system. You stop it, just starting it again is horrendous. You have to start up those great big compressors, everything goes wrong. So operational disruption is probably the worst one on this list, or the biggest reason that we don't do things. But I also think that this one down at the bottom is probably one of the second ones. Up until recently, the only tools and solutions that we could even implement have been based on IT solutions. And previous recent jobs, I've also worked in the IT space, and I know about putting on endpoints. You want to do CrowdStrike, you want to put in Zscaler cloud solution, you want to put in whatever. They were all IT solutions. And IT, think of the first thing you do when you install a security solution. Okay, reboot the system. We can't do this in OT. You're going to shut down the whole environment, and maybe it doesn't even reboot again. So simple things like this mean we can't adopt all of the IT stuff. Nobody's built anything specifically for OT, so what can I do? What can I actually do? So we have some ideas. I'm not going to go into a great deal of detail about this. Everybody knows, right? This is a little bit older, from 22. One thing is that critical infrastructure did, a lot of it is critical infrastructure, did have a fair share of its problems, and we've all been getting hit by this. One of the things I find interesting is this food. Why food and agriculture seems to be getting hit. I don't know whether they're targeting it, or it just happens to be some of the technology there is probably a little bit more lax. It's not quite such a good technology. Yeah, just pointing out some of the simple things. One thing about this is a recent survey, I think it was late last year, and the most interesting part of it is, and I'm not going to go into lots of stats here, we're going into real stuff in a minute, only 40% of the survey said that they'd actually had an assessment. And really, that means you don't know what you've got. If you don't know what you've got, how are you supposed to go forward? So one of the things that we will also talk about is how can I actually identify what I have already? A lot of times there's a system on the shop floor, lights are blinking, it's doing something, you're not really sure, but you don't want to turn it off in case you shut something down accidentally. So if you don't know what you've got, you don't really know how to actually go ahead and implement any kind of security. So 40% is an assessment, meaning they did a security assessment. That kind of implies that you probably don't know the rest of the details either. What do you even have in the first place? So the other ones are people who have had an assessment potentially, or not had an assessment and either had some kind of a security incident or not having an incident. Why does anybody do this? Honestly, I don't really care. I mean, the fact that they're doing it for political reasons or money reasons or whatever reasons, it's almost irrelevant. People are out there doing something, and malicious for whatever their reason is. It doesn't matter. At the end of the day, we just have to secure ourselves so that doesn't happen to us. This one, no worries. So let's get into this. And by the way, I deliberately made this as pretty simple as possible. Don't want to go into technology specifically. I want to go into concepts and ideas. But the idea is there are some things on here that you could potentially actually implement and do, even if you only do a few of them. Any incremental steps that we can do to secure our types of environments is going to be a good thing, right? Don't not do them. The boring one. Sorry. This is a bleed over from OT into OT, whether we like it or not. Every company has an IT side that does all of the business things, and then the OT side that does all of the actual work. I shouldn't say it that way. You get the idea. So we have to communicate. The business side is talking to the market wants data, the data actually comes probably from the OT side, so there's a communications path between IT and OT. Traditionally, we don't do this very well. IT doesn't talk to OT or the other way around, however you want to talk about it. IT is dealing with all of the people, OT is dealing with all of the systems, they don't understand the same protocols, so they don't talk, they don't get it, which is a problem for everybody. So this is the first thing to solve, and I understand there's no technology involved in this. This is just, can't we just get along? Can't we just make friends? We have to communicate so that everybody understands better. We found that when we do go to a facility and we do a walkthrough and we're talking to them, we try and get them to bring IT people with them so that we can all have a conversation. Sometimes this is the first time they've even talked to each other, but this is a really silly place to be. We need to be actually having better communication. So, straightforward. Okay. IT and OT are different. We'll get into this now. But we all know that we can't use the same technologies. This is part of the reason that some of this hasn't actually happened. But I think there's a big benefit to what we have in OT over IT. You might think that IT is further advanced and doing more intelligent things, but not necessarily, and they have problems. In your average IT system, average IT desktop, that desktop is doing so many different functions, right? You're writing an email, you're making a document, you're doing a live stream meeting, you're doing a PowerPoint presentation, spreadsheets, yada, yada, yada. It goes on and on and on. So this laptop is doing tons and tons of things. So it's basically impossible to model what is going on this laptop. There's too many functions involved. But in OT, our control systems, generally speaking, they're a limited function. You might have lots of control systems, but this control system does A, the next control system does B. Very, very different functionality, but it's a limited set of functionality. You're opening a valve, closing the valve. You're changing the pressure. You're running a conveyor belt, a welding machine, stamping machine. It's doing similar functions repeatedly throughout the day and probably throughout the year. This is another advantage. This is part of that advantage. Because it's a simpler set of functions, we can say I know what the function is supposed to be, and I can make sure that I look for this. This is a kind of concept of a model. I build a model of what this control system is doing, and then I can say, I want to watch it now. If this system does anything that doesn't match my model, I want to know why. Now, there's different ways of achieving this, and there's different levels, right? So you need to do this at the control system. You need to do this at the network between the control system and the assets. But we want to essentially do this with models and another thing called trust lists. We want a list of things that we know and we can refer to and say, this is what it's supposed to be like. So, no way you could do anything like this in IT, but in OT it's possible. So this is why I think we need tools and security that's OT specific, because it is specific. All right, let's get into some of the things that we can actually do. Now, you've probably seen some cycles of things like this. There's always a loop of things that you need to do to achieve your actual goal. How are you actually going to get to a state where you're in better position than you were when you started, hopefully. And it's iterative, right? So you start and you go through this loop, and you don't just stop at the end of it and say, okay, I'm good, because things in your environment change and you need to go back and re-adopt anything that may have changed throughout the year or 5 years or whatever it might be. OT, because we don't like change, this is a problem. Nothing actually goes ahead and changes of it. Don't change anything just in case it breaks. That's why we're dealing with Windows XP and 2000 and ancient legacy operating systems, as well as the more modern things. I don't know if you're lucky enough to have the new ones, but quite often we're working with those old stuff that's not even supported by Microsoft anymore, or the Linux platforms. And they've got known vulnerabilities, right? They're old platforms, they've got known vulnerabilities, Microsoft isn't supporting it, you don't get a patch. What can you do to protect yourself with a system that's like this? Air gapping, maybe, things along these lines. But again, so that's the first step is the inspection stuff. So we'll go through these in more detail, but let's just talk about the cycle, and then I'll show you different things that you can do in each one of these phases. So inspect. The first thing you need to do is identify what you've got. Do you really know what you've got in your line, in your production, whatever your service is, in your pipeline systems, in your manufacturing systems? Do you know what you have? People come in and going, operating systems change, things get updated, yada, yada, right? And new pieces of equipment come. So it changes whether we like it or not, but let's at least make a baseline so we know that we're good from the start. So you have to inspect things. Excuse me. And because we're OT, it's very difficult to you can't install so many pieces of software that you would usually use to monitor a control system, because everybody gets upset about installing it, and the install probably says you need to reboot. So you need unobtrusive mechanisms to do this. Can I scan a computer system, a control system, without installing anything? And there are tools that will work with this, and we'll finish up with this in a little bit. So can I do that? And can I scan a system without impacting it? What about when somebody brings in a USB drive to do maintenance? We've got some great examples. I'm working with a food shipping company. The engineer came on board the ship, went to a control system for the refrigeration services on the ship to do an update. He updated the system. Unfortunately, he updated it with a virus at the same time. So USB storage, especially if you're working in an air-gapped environment, how do you update your environment at all? Okay, you can't communicate with the internet and bring down download an update for you. You're stuck. So you need something else that can do this kind of function for you without even, you can update your services inside. So you need the USB, but you need to be able to protect it. We'll talk about things like this as well. So once you've inspected everything, and by the way, you need a kind of an audit trail for that. So you've inspected everything, and you can prove what you have, and you know what your baseline is. Cool. And you know that it's clean, tidy. You've made sure there's no viruses on it. Lockdown, now that we've made sure with what we've got, we want to lock it so that it can't change without our knowledge, without us doing anything. Also, so that we can see if somebody else is trying to manipulate the system and make a change that we don't want them to do. Simple as that. Segment is actually, oops, my bad. Segment is actually the same concept, right? Even that the control systems are doing a limited function, the communications between the control system and the asset is probably a much more simple set of communications. It's probably using a very specific protocol. It's using an OT type of a protocol. It's not doing HTTP, it's not opening Word documents and all this kind of stuff. So we want to be able to build a network map and understand it, and you can do this, trust me, and be able to not only understand it, but then enforce policy on the top of it. I think that's all I want on there. Okay, let's go into a little bit more detail about some of these, all of these steps. So inspect. As I mentioned, you need to know what you have, and you want to make sure that it's clean. Zero trust, everybody talks about zero trust on a regular basis, and it's a good term. It's get overused a little bit, but it's still a good term. But zero trust means basically that you should consider everything guilty until proven innocent. It's not really good in the court of law, but in our case, we want to say, I don't trust anything, I don't know what there is on this system, and therefore I need to check it. So I want to scan it to find out if there's anything on there, and I need to go ahead and inventory that thing as well. So you start with a clean environment. So you get the point here, right? Anything you have, whether it's already there, whether it's coming, whether it's walking through the front door, back door, side door, just scan that equipment coming in. We've got good examples. You've probably read about it, right? So trusted employees or trusted engineers carry malware, just like I was talking about on the ship, on site, in a USB drive, and they've hidden software, malware in the software of equipment that's being delivered. A brand new piece of equipment comes from the manufacturer with that nice old XP operating system on it, and it comes with viruses on it. So somewhere, either actually at the manufacturing facility, it was installed with that for malware, or somebody actually intercepted it on the way to you on a truck. We have examples of this supply chain, right? It happens in that delivery system. So basically what we're saying is even sources that normally you say, I'm trusting. I would trust the manufacturer to send me something good. It's not a good idea. Don't assume that it's going to be good. It has happened coming from a manufacturer with malicious things in. So check it. If you're going to check one system, check them all. Check them all. Now this means that every entry point into your facility, you need to have tools that can do this, right? So you need to check the systems that are arriving, and you need to check the USB devices. Again, this is feasible. There are tools out there that you can do this, and obviously it needs to be quick. If it's not fast, you're going to have everybody backed up at the front door trying to come in. But laptops, should scan those laptops, portable storage devices, and collect an asset detail. So especially when the engineers and people are coming in to do work, make sure that you have a report. Who came in? So this is going to, device will say, scan this thing, look for malicious content, but also make a note of what the device is, what's the manufacturer, what's the operating system, what's the version, so that you can do it for the people that are coming in, as well as, obviously, your own systems. Those are the kind of details that you need to collect. This might sound like a lot of work, but there are tools that literally can do this in just a few minutes at the front door without impacting a lot of stuff. Yeah, you have to make somebody sit down for 5 minutes while you scan his USB devices or his laptop or something, but it's well worth doing. So in a nutshell, let's inspect, right? Now, how can you actually achieve this? Like I said, there are tools already on the market. There's at least 2 companies here today that do a lot of this. So, and that's just in a small sample of the companies that we have here today. So there are other ones out there as well. So you need to go out and find this stuff. And it shouldn't even be too expensive or difficult. A little device that can scan USB drives. It's a station that sits there, you plug it in and it scans it. You need to know nothing, and it will just tell you if it's got malicious files on it or not. A couple of, test them out, obviously, to make sure it does what you're supposed to be doing. Again, make sure that they're quick, because if it's slow, you really do create a backlog and people give up on it. And don't forget for it to make sure that it collects the inventory details. Make it a policy. It has to be a policy so that they don't just let it slide and don't make it happen, because you're going to start introducing holes into the process right off the bat. A bit blurry there. So, we've just scanned everything in our environment. We're now scanning everything coming through the front door to make sure that it's clean already here, and anything new coming in is also clean. So, they're all nice and neat and tidy. Now we need to say, okay, I've scanned it. Let me take my environment and lock it. I know it's good right now, and sometimes you can do this process at the same time. Obviously, you scan it and say, it's good, I'm going to lock it down. So we're going to do trust lists. We're going to make a list of things so that we can actually say, this is my list of known good things, and how can we actually achieve this? So this is just an example. Is it coming up? Yeah. What is a trust list? Trust lists are essentially different for different pieces of the network, different pieces of your environment. So there's a trust list that you might use for a piece of software on a control system. Trust list might be there for the network systems as well, so they're going to be different. We'll talk about a couple of things. For a control system, we know that it's clean. We've just checked it. So I want to make a list of all of the operational files on that control system. So this can be, if it's a Windows control system, it can be tens of thousands of files, because Windows dumps all sorts of stuff into it. It's got a huge bloat of executable files that probably you're not even using, but they're in Windows, even if you try and clean it out. So it will be a list of all of the executables, DLLs, probably BAT files and things like this that are going to run on this control system. And now you want to say, okay, this is a list. Oh, and the operational tech, right? So the actual operational technology, the operational tool on this thing, the Schneider electric pieces or whatever it might be. So you're going to have a list of everything that can execute on this system. Now, anything that's not on this list, you could say, okay, I have a list of known good things. This is allowed to run, and I'm going to keep it safe. You can't change it. I'm going to lock it. I'm going to lock that list down to say these are the only good things that are available. And anything that's not on this list, I'm going to say it's not allowed to run. It's not there in the first place. I didn't inventory it. Why should this new piece of thing execute? So think about a piece of ransomware. It's brand new. It came out this morning. Right? It happens all the time. And there's no signature. There's no way for you to detect this. So how can you possibly protect yourself from this new ransomware? This new thing, it's going to run. It's going to do. So antivirus. If you're running in an air-gapped environment, you probably haven't got an update, and you're not going to get an update till the next window opens up when you can update your antivirus, which is going to be in 3 weeks, 3 months, whenever the heck it is. So you've got an AV, maybe you have an AV, maybe you don't, because it can't work properly on the control system. But in this case, we don't really care. I've got a list of things that I know are good and they can run. A virus piece, another executable showed up that's going to do something malicious. I don't know if it's malicious or not, but I don't really care. It's a new piece of executable that I've never seen before. It's not on my trust list. It's not allowed to operate. Just turn it off. It just says, no, I'm not going to allow you to run it. So it's a really neat way of, it's perfect for OT, right? It's not connected to the internet, it's air-gapped probably, even if it's not. It probably still doesn't have the latest AV, and maybe the AV doesn't even have a signature for it yet anyway. So it's irrelevant. It doesn't matter. I don't know whether it's good or bad. Don't allow it to run. Now, similarly, A lot of control systems are running scripts of some sort, right? So you might be using PowerShell or C script or something along these lines. And PowerShell is brilliant. You can do so many different functions with it. Unfortunately, so can the bad guys. You can just get on, the PowerShell is already there. This is what they call a living off the land attack, right? It's something that's already on your system. They didn't even have to transfer anything to your system. They're just making use of something. They managed to get access to your system. They're making use of something that's already there, running it, and doing some damage. They can just use PowerShell command to shut down the system. It's literally a commandlet in PowerShell, shut down the system. And then all hell breaks loose. Your whole environment just bit the dust. So you need to be able to build a list of valid PowerShell commands. You can do this. There are tools that can do this. So build a list of all of the good PowerShell commands that operate on this system. And now, if somebody comes in and tries to do PowerShell, we say, yeah, PowerShell's cool, but it has to be one of these on my list of commands. Nope, it's not on the list of commands. I can't do a shutdown. I can't connect to this system, however I did that, and then run a PowerShell command that's not legitimate. So it's just a way of saying, again, we know a list of executables, we know a list of commands that are normally operating on this system, and nothing else is allowed to work. Really good for OT, because once again, there's probably a limited set or a specific set of functions that that device is actually doing, and so the commands are a specific set of things that are just repeating all day long. A couple of other important things about, this is software, this particular piece. So USB, we're locking down a system. You have to have some software to do this. We'll talk about, obviously, one of the things you need here is that it doesn't need a reboot on install or update. So you can do it. So, but the other thing is the USB drives. We talked about scanning USB devices coming in to do maintenance. What happens if that engineer had a USB in his pocket and he didn't tell you about it, and he walked in, he gave you his other one that he doesn't care about, and you scanned that, and he's now got a USB in his pocket? If we put the software on this control system, you can have a logic that says only use permitted USB drives. The company says you can use USB drives from whatever, SanDisk, the serial number's 1 to 10, and the model number is this, and the serial numbers is 1 to 10. If you're not using that USB drive, the USB port will actually say, no, I'm not accepting usage. You need that USB drive, especially if it's in air gap. Some people put glue in their USB port, right? So you can't use it, so you can't get damage from it. But if you're air gapped, now you have a different problem. So let's say the USB drive is active and you want to use it. Excellent. But put a control on it so that it only lets the registered USB drives actually function in that system. Another way of locking it down. I talked about the no reboots part. The other thing is, we're talking to a customer right here or somebody yesterday, not allowed to install things because of the overhead that a new piece of software could install, especially on an HMI system or something like this, which has probably got limited resources. So this software needs to be very, very lightweight, and which is generally something that we do that is built for OT systems. It's going to run on a lightweight system. It's going to run on a legacy system with less memory and probably less CPU cycles. So there's no point in having a big, heavy, I used to work for Zscaler, big, heavy Zscaler agent or CrowdStrike agent or any other kind of agent. First of all, it doesn't run on a legacy system. Secondly, it needs to talk to the internet all day, every day, things like this, and it's really heavy. It takes a lot of resources. So you need to be able to do this, but you need to be able to do it light. Don't impact the system. So we've already got 2 out of the way. We're doing well. So there are solutions out there on the market. Like I said, there's a couple of companies here that do a lot of this stuff already, and that's just here. So you can do it. Now, this trust list works perfectly well. I know everybody has a little bit of a resistance to installing something. If it's built for OT, it's okay. Test it out, build it, try it. So yeah, they must, whatever you get, if you've got legacy systems in your environment, make sure it supports legacy systems, because they're probably not going to go away for a very long time. They've been here for 25 plus years on the old versions of Windows, and so they're probably going to be here for another goodness knows how long. Eventually they'll go away. But make sure that it's supported and going to continue to support that. If we want to build that trust list, that's a fairly straightforward operational thing of saying the executables. Try and make it do the next step and do things along PowerShell, because living off the land attack is great. If they get access to your system, you're in trouble. right? If they get access to a system with any kind of a lockdown, doesn't matter, they can't operate, they can't do any other damage on that system. To make things really easy, they need a maintenance mode. You are going to make legitimate changes, or you're going to have an engineer that comes in to make legitimate changes. So you need to have a mode of being able to essentially adopt new legitimate changes. Not something that happened accidentally you didn't aware of, that's going to get blocked. Maintenance guy comes in, you need to have a maintenance mode that says, I'm allowing these changes to happen, and I'm going to now adopt these changes. I know this sounds heavy. It's really not heavy. It just has a maintenance mode. You put it in maintenance mode. It takes any new changes and adapts it into the model. So it's a really good way of doing it. Let's see. Yeah, don't require reboots. We're already out of luck. Okay, so we've identified everything. We've locked it down now. We've built our inventory list, and we've identified everything we have. We've built a lockdown for the control systems. Now we want to say we know exactly what the control systems are doing. We want to see the communications between the control systems and the actual assets, right? Now this is probably, again, way outside of IT world. It's going to be using completely different protocols. We're going to be using Modbus. We're going to be using SIP. We're going to be using whatever, all sorts of other different protocols. So at the network layer, we need something that understands OT protocols. You can build a basic segmentation that says this IP is allowed to talk to this IP, but really we want to go deeper. We want to be able to say this IP can talk to this IP using specific protocols, and if you go even deeper than this, to say using specific commands within those protocols. So it's a very, now you can start to getting really clever. Now, it's much more specific. Like I said, in IT, you've got all of this stuff going back and forth. A lot of it is going to be HTTP, but it's tons of, HTTPS, it's tons of completely different variable stuff. Can't possibly model it. OT, we've got that benefit where it's probably sending a specific set of commands repeatedly throughout the day, and then all day, every day, and going forward. So it's a limited set of commands. Could be a big range, but it's still not huge. It's manageable. So the benefit from the OT side. So you want to make this automatic, and it needs to be, so it needs to learn. You want it to actually identify the correct protocols, understand those protocols, and be able to build a model of the protocols. Understanding the protocols is good, but actually being able to prevent things is going to be the important part, right? So it doesn't just model what is there and then just create an alert that says, hey, I found a weird protocol, or even a weird command. It's going to actually say, I can do something about that. So the fundamental tools of network segmentations are obviously, generally speaking, network devices. You can do some things with switches and routers to actually segment your network for you. But those things don't understand OT. And another thing is they're more intrusive. You've got to do some re-IP structuring of your network just to put in a network device. But if you've got a good built for OT IPS system that does not require IP addressing at all, it's completely transparent on the network, doesn't impact anything. Yes, you have to unplug a wire and plug in another one. Hopefully you have some switches that you can work between and just create a new route with a new device in the middle of it, and then unplug the other one. The traffic just routes through the new route. So it can be a network transparent, I like that term, device. Doesn't even have MAC addresses. It should have fail open, fail close kind of capability. So if you pull the plug on this thing, it does actually turn into a wire so that you can continue operating, or not, depending on your config. So you should be able to actually plug in a network device that will understand the protocols. Cool. Now, ideally, do you really want to go through and figure out the command sets that are actually in operation? No, that would be awkward. I have to go in and figure it out. A learning mode. You plug this device in, it looks at the traffic, and it says this is Modbus, and it's doing these commands. It will add them to a list of command sets, and then you can take it out of learning mode and actually make it do work. So you don't really actually have to do a lot of work. You have to do a bit of physical implementation, but it will do all of the work for you. It will learn the IP to IP. We're going to say, okay, IP1 talks to IP2. That's one of my paths. IP10 is talking to IP20. IP100 is talking to 200. On one of those connections, the IP10 is talking to IP20, it's using Modbus, and it's reading specific coils and writing certain registers. So this will give you those that network segmentation automatically. You don't have to move any wires, but it's going to build a rule set that says, I know only 10 can talk to 20 and 1 can talk to 2. If something else tries to use a different path, it's out. Can't do it. Yeah, it should go down into the deep, the actual protocols. So just a little bit of an example here. Excuse me, sorry. The policy rules say that the HMI system over here, or the SCADA system, can only talk to the PLC on the bottom right-hand side, and it can only communicate with Modbus. And it can only read coils, if you're familiar with Modbus, it can only read coils 2 to 4, just making up some commands. But it knows specifically that's what can happen. And on the other hand, the workstation over here can read the same coils, but it's got read-write access, right? So it can also write the registers 5 to 7. Really specific controls. That's the only thing that this whole environment is doing. Okay, there's probably a bigger list, but you get an idea. That's literally this list of commands can work, this list of commands can work, nothing else can work. Very, very tight segmentation. So, how can you make this happen? You know, there's quite a big list here, obviously. It's quite seeing. I've highlighted protect because you know, we're very leery of actually implementing things that block stuff, but this is OT. It understands your OT. It understands your communications, and you want it to actually prevent. If something really is out of whack here, it's not normal, it should go ahead and actively block what you're doing. Obviously, you can run this in monitor mode only and get alerts. But I think, you know, we need to start moving beyond actual just alerting and actually implement blocking. And because this is OT, doesn't require a big painful installation, doesn't require any heavy-duty install instructions. It literally, all of this stuff really learns by itself and figures it out, and it will do it for you. It will build you all of these details for you. Learning mode is very important. It just makes it a whole bunch easier, because you can go in and manually create this, but that would be a bit of an awkward thing to have to do. Make sure it does IPS protection, right? So we'll talk about this in one of the last stages. You know, you need to be able to protect things that you can't install anything on or that have specific problems. You can potentially protect a system with an IPS system in front of it. We'll talk about that a little bit more. But there, yes, it'd be very important to have an IPS protection built into it. Network transparent, no changes. Yeah, and oh yeah, bypass. So up to you. Some places want to fail open, some places want to fail closed, and I know that varies on industry, which is open and which is closed. Redundant power supplies, OT, right? Make sure that it's got all the things that you need to actually keep everything running in the worst case scenario. So the last one, reinforce. We talked about it a little bit earlier. One of the problems we face is old operating systems. They're probably, goodness knows how long, right? I mean, really, really ancient stuff. Like I said, 20 plus years old. We've got all of the Windows and even some Linux systems out there as well a little bit. But they don't have any support. There's nothing you can do. This means that sometimes there isn't even an available patch, right? Something's recently happened. There's no patch for this, so at all. And if there is, you're probably not allowed to implement it. How am I supposed to implement this patch? My operational cycle says, no, you've got to wait for 2 more weeks, 2 more months, or whatever, until there's an open window for maintenance. So while you're waiting for the patch, or approval to patch, you can use something called asset shielding, which essentially says, let me use my network device to try and identify traffic that is attempting to take effect on that vulnerability in the system. So it's looking for traffic that's trying to implement that attack. So, and blocking it at the network layer. So this is a little bit of, yeah, so I think in OT, this is one of the important pieces as well, right? So it's detecting and blocking traffic at the network layer before it even actually reaches your device. So that, yes, you can't put a patch on it yet. My maintenance window doesn't happen, but I want to actually protect it at my network that I can put into the IPS. So it is important to have that network device with the IPS system on it that is preferably up to date, because, again, as long as you can update it without impacting anything. So it will protect you and give you that, you've got a vulnerable system, but you can protect it until you have the opportunity to actually patch it. Keep it going while we wait for an available operational window. Mean time to patching, right? So how long does it take you before you can actually get your patch applied? Don't set and forget. You have to go back around this loop. Now that we've detected and checked everything that it was, and it's all locked down, you might kind of say, okay, I've locked it all down and I've built it. Can I just leave it alone and let it operate now? It won't happen, right? It's going to change. You're going to have some engineer that comes in to make some updates on one system. That system is now a little bit different than everything else. And maybe even at some point or other, they're going to replace a piece of equipment. So things are going to change. So eventually, you're going to need to sort of repeat this whole cycle again. Just keep doing periodic checks on things as well, right? So you can just keep checking to make sure that you haven't introduced anything unusual. Pick a time, once a quarter, once a 6 months, or whatever it might be, whatever is operationally acceptable, shouldn't be impacting anything, and so you should be able to do it. And once again, make sure that you're scanning everything that ever even showed up in your environment. Keep it going, because anything new is just going to mess with your environment. So how can you make this? What tools can you do? Note the bits in red. Those are the most important things I think I mentioned. The importance of keeping your IPS system up to date, because it can save you in the event of an actual attack that you can't patch anywhere else, or there isn't a patch. How do you protect yourself? So the IPS system can potentially provide that security for you. Do this. Keep going with the periodic system checks and scan everything coming into your environment. So we've just been around our entire loop, pretty quick, I think. I don't know how much time I've given here. Am I over time? Possibly. So inspect everything to make sure it's clean in the first place, systems and storage. After inspecting everything, we're going to lock it down so it can't possibly change, and segment the network all the way down to the protocol and even the command level within the protocol, and then continue to scan all devices that are coming into the facility, scan all equipment that are entering your facility. That's it. Lock it down. Thank you.